let A be a 3 cross 3 matrix, determinant of A is 2, and N is determinant of adjoint of A, and here we have this adjoint 24 times. If this number N is divided by 9, then we have to find the remainder, right? So this is another interesting problem from matrices and determinant, and it also involves concepts from binomial theorem, right? How to find remainder when a number is divided by another number. So first of all, this given number n, I'll represent this number by capital N. So let us say this number n, this will be determinant of A raised to n minus 1 and that raised to k. This is the standard formula for finding determinant of adjoint of a matrix, where adjoint is given a number of times. In this formula, n is the order of matrix. For example, here we have 3 cross 3 matrix, so that means n will be 3. And k is the number of times we have adjoint. For example, here we have adjoint 24 times. So that means k will be nothing but 24. So determinant of A is 2, n is 3, so n minus 1 will be 2. And then this raised to 2024. This is number n, and this number is divided by 9. So then we have to figure out the remainder. Now remember, when we are dividing by 9, we have to see that which exponent of 2 that will be multiple of 9 plus minus 1, right? So clearly you can see that 2 cube, this will be 8, and 8 is nothing but 9 minus 1, right? So here basically first we'll try to identify this number 2 raised to 2024, right? We'll try to figure out that 2 raised to 2024, is it multiple of 3, multiple of 3 plus 1, or multiple of 3 plus 2, right? Because that will give us, that will, in that manner, we can write this as 2 raised to multiple of 3 plus something, and then we can use the binomial expansion because 2 cube is 9 minus 1 and we are dividing by 9. So here, 2 raised to 2024, this you can write as minus 1 plus 3, and this raised to 2024. And now if I expand it using binomial theorem, then clearly you can see that minus 1 raised to even power, that will be 1, and after that all the other terms will be multiple of 3. So that means 2 raised to 2024, this is nothing but multiple of 3 plus 1. So therefore we can write this number n as 2 raised to multiple of 3 plus 1, right? 2 raised to 2024, 2024 is multiple of 3 plus 1. So this number n will be 2 raised to 3m plus 1, where m is some positive integer. Now here you can separate this 2, and then this we can write as 2 cube raised to m, and 2 cube is 8, 8 is minus 1 plus 9. So we have minus 1 plus 9 raised to m, right? We are trying to write this number capital N as multiple of 9 plus something so that we can get the remainder. Now this becomes 2 into, and then if I use binomial theorem here, then we'll get minus 1 raised to m plus, and after that all the other terms will contain at least one 9, right? Next term will be mc1 into 9 raised to 1, next term mc2 9 square, and so on. Alternately we have to change the sign because of this minus 1, but the point is that only this first term will not contain 9. After that all the other terms, there will be multiple of 9 only. So therefore we can write this number as minus 1 raised to m plus 9 into some integer k, right? K is some integer. So now we have to find whether m is odd number or even number, because if m is odd number, then minus 1 raised to m will be odd, and if m is even number, then minus 1 raised to m, that will be even number. So for that we have to see this equation, right? We got 2 raised to 2024, this was multiple of 3 plus 1. Left hand side is even number, 2 raised to 2024, that should be even number. So that means right hand side must be even. If 3m plus 1 is even, then 3m must be odd, and if 3m is odd, m must be odd number, right? Because if m is even number, then 3 into m is even, even plus 1 will be odd, and the left hand side is even. So then we cannot make the two sides equal. So from here you can very easily see that m must be odd number, then only we can make the two sides equal, right? So if m is odd number, then this number n, this will become 2 into, and multiple of 9 minus 1, right? Minus 1 raised to odd number, that will be minus 1. So therefore, this number n, this will be 2 into multiple of 9 is still multiple of 9 minus 2, right? So the required number n, this will be of the form multiple of 9 minus 2. And if I divide this number by 9, then the remainder will be minus 2 plus 9, right? Remainder is never negative. If we get negative remainder, that means we have over divided. So that means we need to add 9 here. So if the number is of the form multiple of 9 minus 2, that means it is of the form multiple of 9 plus 7, right? So if we divide by 9, the remainder must be 7. So therefore, the correct answer for this problem, that will be 7, right? So this was one very interesting problem from matrices and determinant, and also it has concepts from binomial theorem. From matrices and determinant, this number n will be 2 raised to 2024, because adjoint was 2024 times and n is 3. And then first we have written 2 raised to 2024 as multiple of 3 plus 1. And then after that, finally we got this number n as multiple of 9 minus 2. If we divide this number by 9, the remainder will be 7. And therefore, the correct answer for this problem is 7.